Hi, welcome to class. My name is Don LaFon, Professor Don. Welcome to our first chapter of our A plus hardware course. Now, the college I teach it at, the college I teach it for, the name of the course is CTS1131C, but if you're taking it at a different college, it's the same course probably that you're taking, so hopefully my presentation will be helpful for you. If you're watching this and you're in my class currently, please hold your questions to the end of the presentation. I'll give you an opportunity to ask your questions. Make note of them. Or you can ask your questions in a help discussion forums inside of our Canvas classroom. If you're watching this presentation on YouTube, and you have a question about anything we talk about, please ask your questions down below in the help discussion forums, and I swing by every now and then. I answer those questions, but of course, it's an online community. Please answer each other's questions. I love to see that when a community forms around something that we're currently teaching. Anyways, let's go ahead and get started with the presentation. This presentation should be about half an hour, maybe a few minutes longer than that. It's our very first presentation, and this presentation is pretty much just an introduction to what we're going to cover all semester long. We've got 15 weeks ahead of you, 10 or 11 chapters, and this is just kind of introducing you to the whole course. If you're new to IT, new to hardware, this is just touching the concepts that we're going to cover for the next 15 weeks. All right, so let me go ahead and start this presentation from the beginning. And I've got to do something on this end. Drag this over here. And I need to minimize this window. A couple things to make the screen look right in front of me so that the presentation goes smoothly. All right, I think we're there. Introduction to the World of IT, Chapter 1. By the way, the book that I'm using for this presentation is based on Cheryl Smith's book. The book is The Complete A+ Guide to IT Hardware and Software. This is the textbook, and I'll put a link to it down below in the notes underneath the YouTube video so that you can find this book if you want to have a hardcover book to go along with the course. This is the book we're using, and hopefully it is helpful for you to get your A+ certification. That's what the goal of this course, A+ hardware and the A+ software follow-on course. When you complete these two courses, you should be ready for your A+ certification. All right, here we go. This presentation covers examples of IT roles, qualities of a good technician, basic computer types, important computer parts, Windows environment, the Windows environment, and basic computer terms. IT roles. The IT field is huge. I always talk to my students about the fact that the only people that think that they're 10s on a scale of 1 to 10 in computing are people that really just don't know how big the IT world is. For example, I've had several students over the years that I'll ask them where they are on a scale of 1 to 10, and they'll tell me a 7 or 8, but they can't ultimately attach a file to an email, or they can't add a table to a Word document. They can't do a formula or a function in Excel, or they can't network a computer hard Wi-Fi, or they don't even know what an RJ45 cable is. So or they don't even know what programming is, never mind know how to program in 5 or 6 languages. The IT field is huge. There are jobs that I've personally done, in addition to being a teacher. I was customer support. I took 30,000 phone calls for AOL back in the day. I know, that ages me a bit. But I worked for America Online back when it was the way that everybody connected to the internet. And I took 30,000 tech support phone calls back in those days. So I know a little bit about customer support. I know what it's like helping people that don't know what's going on a computer, because I helped a lot of students back in the 90s in the late 90s and early 2000s with their computer access and getting online, and then what to do once they got online. So you can do lots of stuff in IT. You can do PC repair, you can build databases, you can be a network administrator. You'll see inside of my YouTube channel that I also teach Cisco. With networking, with networking and Cisco networking, you can make 100 grand after a few years being in that field. You can be server administrator, where you set up email servers, web servers. There's, I don't know, 10 or 15 different types of servers that you're responsible for setting up for a big company. You can be something simple like installing cable, right? They make good money. If you got your own company and you're installing cable and you're a contractor, you're making good money. You're working really hard. It's pretty simple work, but heck, it's a job, and you can make 100 grand or more doing that if it's your own business. If you're doing it for somebody, 15 bucks an hour. You can be a data analyst. One of my other professions is business, and I worked on my doctorate degree for a while, and I'm very familiar with being an analyst in a corporation. If you're a data analyst and you can turn data, like all of those swipe cards when you go to a grocery store and you swipe your VIP, it's recording all of your information. If you can turn that data into information, that the company can use to make money, then you will make a lot of money for yourself. Whether if you're doing it for yourself, you can make a lot of money for a company. Help desk support, that's what I did for a while. I might have told you when I worked for America Online almost 20 years ago. It was 20 years ago. When I worked for America Online, I was working at one point sales after doing help desk support for AOL, and I was making probably close to 100 grand back then. Now, I was exceptional, of course, but that was a long time ago. You can probably expect help desk to be a more minimum wage, $10 to $15 an hour job, but it's a great first job in IT. It was my first job truly in IT. I was in the Navy for 20 years before that, but it was my first real world IT job, and it was fantastic experience for me. Help desk support, I highly recommend it as a first position if you can't get any of the other jobs because of you don't have enough certifications and whatnot. Programmer. Programming, it's not my specialty, but I'm actually learning how to program now. I'm in a Python class right now, just finished my COP 1000. I know some of you are saying, what, you don't know how to program in 5 languages? As I said earlier, the IT field is so big, we all focus. I focused on Cisco networking. Some people focus on big data and database administration. People will be hardware PC repair techs. Some people will work in help desk their whole life because that's all they want to do. Some people will be programmers, and that's just a field. If that's what you like, then that's what you will want to do. We touch on that in this A+ course, and if it's for you, again, 100 grand. You can be set up for life if you know how to write programs. Heck, write an app for an Android phone or an Apple phone, put it out on the Apple store, and if 1 million people pay you $1 to download that app, you just made about $400,000 after taxes and the fees you're going to pay Android and Apple. But it's $400,000, right? So programmers out of this whole group are definitely the people that are in a position to probably make the most money if they're actually writing their own programs. All right. So enough of this. So lots of jobs inside of IT, and you'll find a niche that you enjoy, and you might even find it in this course. Now, what are the qualities of a good technician? We know what it's like to call tech support. We know when we call tech support and we get a good technician, or we get somebody that's just reading the screen. We know when we call the IT department at our job and we get a good IT person that's able to talk to us, or we get somebody that is just I call people that are just techies. I call them nerds. It's not an insult. I call myself a nerd. Um, it isn't an insult. Go online. There's lots of people. I call themselves nerds. Nerds basically just mean you know a lot about computers. Now, if that's all you know and you don't know how to talk to people, you don't know how to listen to people, then you are going to have a challenge to be successful. You're not going to be a good technician, and that's the first step in any job, being able to communicate. To be able to be a good technician and to be able to have soft skills, you need to be able to demonstrate active listening. That means to listen carefully. Don't interrupt what somebody says when they're talking. Listen to their entire explanation before you jump in. You may think you have the answer, but maybe something that they tell you 3 or 4 steps later is going to help you narrow down the problem. So let them speak, right? Make good eye contact. Show that you're following the conversation by nodding your head, hums. Avoid distracting activities like clicking on the web or surfing web pages or playing on your phone, obviously. If they're talking to you, listen to them and pay attention to them. Clarify customer statements by asking related questions. So I like that, call that follow-up questions. So if somebody gives you a spiel ultimately saying that they can't get online, and then you apply back and you ask a follow-up. So you say, oh, so you're having a problem signing online. What have you tried so far? It's like, well, I turned on my computer, but nothing happened. Oh, so you're having a problem with your computer loading. Yes, I just have a black screen. Okay, so that's why you can't get online. So the follow-up step from a technical point can help narrow down the problem. If you immediately start talking about cable being down, or making, if you work for the local cable company and you immediately start troubleshooting your end of their connection, well, they can't even get power to their computer. That's why they can't get online, right? Avoid interrupting the customer. Avoid condescending behavior. And ask open-ended questions. Instead of yes/no questions, let them talk. Let them help you. Did you pour water on your computer? Is that why it stopped working? No, don't do that. Say, do you have any idea what may have caused this problem, right? They probably won't say that they poured water on the computer, but they might say they noticed a little puddle around the computer when they came into work today. That may help you to narrow down the problem. Avoid interrupting condescending behavior. Please, everybody is at a different level. There are people in this class right now that know very little about computers. It's okay. You can go from knowing nothing about a computer, not even knowing how to click on a mouse. I had a student in a course I taught before that she entered my course not knowing how to click on a mouse. She was an older woman. She had never used a computer. She didn't know how to. When I said double click, she didn't even know what that meant. She didn't know left click, right click. That might be you. I'm not making fun of you. This is going to be a little bit of a challenging course. If that's where you're starting from, I encourage you to perhaps start at a lower level and watch some videos on how to use a computer before you start getting into building a computer. But don't be rude to those type people. Don't say everybody knows how to click a mouse. What do you mean you don't know how to click a mouse, right? Don't do that. Everybody is at a different level. Think of some of the things that you don't know that other people know, right? You're not a doctor. Well, maybe you are a doctor, but let's say you're not a doctor. I'm not a doctor, right? A medical doctor, and let's say my shoulder's hurting, right? Well, you don't want to be the doc. You don't want the doctor to say, "Well, don't use the shoulder." Why would you use the shoulder? It's like, well, why'd you pick up that that weight or whatever it was that hurt you? Why'd you throw that ball? Why'd you fall, right? You don't want that. You just want your doctor to understand what's going on, ask the right kind of questions to be able to help you fix your shoulder, okay? All right, let's keep going. Active listening, closed-ended questions. Those are yes/no questions. Don't ask those kind of questions. Instead, ask open-ended questions. I saw where you logged into the printer. I saw where you logged a printer problem today, Bob. What happened, right? Let them tell you what happened. So instead of saying you're having an email, do you have the conversation? What email issues are you having? Let them explain it to you, right? A good attitude. See every issue as an opportunity to help. I like to see every issue as an opportunity to learn. Every time I'm helping somebody else, whether it's building a YouTube video, helping a person to helping a person to learn how to use a mouse, I use that as an opportunity to learn. Be sensitive to other cultures. Some people in other cultures have different learning styles. You need to be aware of that. Take the time to listen to the entire problem. Avoid blaming others. That's what engineers do, or that's what people that love Microsoft products hate Apple, right? It's just a thing. It's an Apple problem. Your problem is you got an Apple problem, right? No, if your job is to help, let's say, students access the internet and they're on an Apple computer, you can't say go buy a Windows computer. You can't do that, right? You have to help them with their Apple, and you can't make fun of their Apple. You might hear me making fun of Apple, but I try to do it in a funny way, not as an insulting way. But don't blame others. Don't blame companies. Don't blame other people. Just solve the problem. Do your best with every opportunity. And they just show that if you don't do any of these things, you have a 0% chance of success if you don't start with that positive attitude. You do all of these, you got a 100% chance at least of starting with a positive attitude of solving the problem. Apply logic. Recognize computer technology, speak clearly and concisely to others, stay current in the latest information, research information to help solve problems, and use deductive or inductive reasoning to troubleshoot and repair problems. I love Google. Most people do. I Google things all day, every day. When I don't understand it, I Google it. It's just what we do as a culture. That's what we all do as a culture, right? When I get an error message on my computer, the first thing I do, if my computer's still on, is I Google what that error message is, and it tells me what the problem might be, right? I stay current with the latest information on my AI. Whether you have Alexa or you have Google, you want to sign up for some sort of daily tech briefing, right? I have one every morning. In the morning, I find out what happened yesterday, and for an about 5-minute tech briefing. Sign up to blogs inside on the internet. Join groups. Find other people that are learning the same thing you're learning and join with them to learn together. I teach Cisco primarily. You'll see my Cisco videos in my YouTube classroom. And I've made videos of all of the PowerPoint presentations in the class, but I haven't made PowerPoints of all of the individual packet tracer assignments. And the reason I haven't is because other people have already done that, right? You get stuck on an assignment, I promise you there's a good chance that somebody has made a YouTube video that will help you to get through that step, learn that process. And it doesn't have to be IT, it could be anything you're learning. I remember when I took my calculus class, I hadn't had an accounting class in 10 years. And the first day of calculus class, I was completely lost. I had done the prereqs, but I had done them so far in the past that I had forgotten algebra. I just jumped on YouTube. I found somebody teaching the course. I watched all 14. Did I say accounting? I meant not accounting. I didn't know how to factor. I didn't know what is it that you need to know to I forget what that term is when you what you need to do to be able to do calculus. You need to know algebra. That's it, algebra. So I just watched 14 videos, 14 hours of um, of YouTube videos on algebra, and I was back up to speed again, and I was ready to go. So please research information whenever you get stuck. And then obviously, the more you know about whatever it is that you're talking about, the more you know about it, the more you're going to be deductively determine what the problem is, or inductively troubleshoot the problem, right? Uh, when my computer went off the other day during a presentation, I immediately thought the power supply went down, and I went searching to figure out if my power supply was dead. I said, well, maybe I need to check the surge suppressor first. And sure enough, my surge suppressor had gone off for some weird reason, and it made it look like the power supply was off. But so before I started ripping the power supply out of my computer, all I had to do was reset the surge suppressor. It happens again 2-3 more times, I'm going to replace that surge suppressor. All right, let's keep going. So apply logic. Search for information. Use descriptive words when you search. Remember, you don't need the, and, at, for, just the key terms. Earlier, I did a search for M2 drives, right, to show my students how easy it is to find something. Stay simple. Instead of writing paragraphs, write individual keywords. And instead of using verbs, use nouns. Use quotes around exact phrases like error messages that you have. Use or, for the example, dot matrix or impact if you want one or the other. Use and if you can't, you're probably not going to get a web page with and unless they're just in general in nature. Use the minus sign to eliminate. So every now and then you're doing a search. For example, my wife was trying to find out how much chicken to feed my older dog because we stopped feeding her dog food, and now we're cooking chicken for my older dog. And she wanted to know how much to feed her in place of the dog food. I know, a little insane, but it's what we're doing. And every time she searched for chicken and feed dog, somebody was selling a chicken product, right? So she subtracted the companies that were showing up, and it helped her narrow down the search to ultimately find the topic that's just talking about how much chicken, real chicken, to give to the dog. And if you want both top words, so computer and memory, and then it also helps if you include the vendor. So if I'm looking for a Cisco specific error message, then I'm able to find it using, if I add Cisco to, how do I set the host name, or maybe VLAN, Cisco VLAN, CLI for command line interface, enter, and it'll give me the commands for configuring VLANs on a Cisco network. So be a jack of all trades, but remember, you're going to focus in whatever topic you're currently in. But you, in order to be a 10, if you think about it, you need to be able to be an operating systems expert. You need to be great at hardware. You need to be able to install and operate software. You need to be able to talk to people. You need to be able to be patient, listening to the entire problem. You need to be empathetic and care about the person that you're helping. You need to be able to juggle time and priorities, right? Because now I tutor occasionally on the side, and when I tutor people, they have a lot of things they want to cover. Well, I'm only with them for 2 or 3 hours each time. So we have to narrow it down to the most important thing that I'm tutoring them, and then we're able to get the most important things done. And the next time I come out to tutor, I'll help again with the next most important thing. Solve the problem. Don't give up. There are answers to every problem. You just need to find the problems, right? Don't quit. And then ultimately, you may be the translator. You may have to turn a technical question or a technical term into something they understand. And it's great if you can do it with real world examples. Right? Now let's go ahead and talk a little bit about the hardware that you're going to cover in this class. This is an overview. We are going to have individual chapters and modules where we talk about the hardware. We're going to talk about different computer types in this semester, whether it's an all-in-one computer where all of the little pieces are built into the monitor, or it's a full desktop tower where you have individual hard drives and a motherboard and RAM, and you can exchange and switch out all those items, or a laptop. Maybe this laptop that you have, it can be really small, it can be really big. They have gaming laptops that have screens that are 15 inches or 17 inches with full, at the best video cards at this point, RTX 3090s. And we have laptops that are as powerful as many full towers, right? If you're a gamer and you like to travel for gaming, then you might have one of these powerful computers. Or you have a completely different laptop if you're a college student. You have a completely different setup on your laptop if you're a business professional. So we're going to learn a little bit about laptops. We're going to talk about tablets and phones and phablets and lablets and combinations of all, laptops that turn into tablets, phones that fold, and we'll talk about all sorts of different types of hardware. What's common to all of that, all of those devices, all of them, even the smallest smartphone that you have, all the way up to the full-blown desktop, is they all have device drivers. Those are the little software, and we're going to get in depth in all of this. But drivers are basically the program that helps hardware work with software. So your operating system, when you first turn on your computer or your phone, you may want to run something on that phone, maybe a new printer, for example, and it needs a driver so your computer can talk to your printer, or maybe wirelessly your phone can print to your printer that's connected wirelessly, right? Hard drives are storage. We have a whole module. We talk about hard drives and storage devices to store the information. We have video cards to process video. We'll talk a little bit about mining when we get to that point, because it's very common, people using video cards for mining. A keyboard for typing, whether it's a digital keyboard on the screen of a phone or a physical keyboard that you work with. They all have displays because, well, the consumer devices have displays. Some computers don't necessarily have displays. For example, they might just have warning bells or alarms that go off. That is a form of display, but maybe you have embedded devices in everything from tennis shoes that can keep track of how far you've ran, to the smoke that comes out of energy plants, and that those embedded devices have different kind of displays, right? Power supplies to power all of these devices, motherboards, all this stuff connects to the motherboard. The case, the motherboard, and all this stuff goes inside of some sort of case, whether it's a big full-blown computer case or a phone. Your phone is a form of case holding all of these things, right? A mouse, something to interact with the case. It might not be a traditional mouse. Maybe you have a thumb mouse. We'll talk about all sorts of input devices and memory, short-term memory, RAM. We'll talk about that as well. We have a whole module about that. These are all of the different parts that you're going to talk about, we're going to talk about in this class. And here you just got some pictures of this stuff where we're talking about displays, or as I talked about, a motherboard having a video card connected to it, and a keyboard or a mouse connected to the ports on the motherboard. Sliding RAM, you can see some that's in the motherboard over here, all sorts of different varieties of RAM. And you as a technician need to be able to order the right RAM for the right motherboard and the right processor, CPU. Oh, they didn't put CPU here, but CPU is the brain of a computer. You need to put that in the motherboard to do the processing or the thinking, right? Computer parts, a power supply is what it looks like. Optical drives, not so popular anymore. They're kind of gone the wayside now that we all have USB drives, right? Now we use these USB drives. And if you buy a computer, if you buy a new program, you're either downloading it or you're loading it to a USB drive to load onto your computer. Even something like a recovery disk with the Windows operating system, even that recovery disk nowadays loads onto a USB drive instead of loading onto burning a DVD like we used to back in the day. Some people still have optical drives, and you have to be aware of it if you're going to be a PC tech helping people out, right? There's the case. Everything goes inside of the case. Data storage. Now, all of these things, no matter what we're talking about, we're really talking about ones and zeros. How do we store those ones and zeros? We're really talking about bits, on or off. A byte is 8 bits, right? And that stores one location. And in that one location, you can store something like an ASCII character, like the letter A, the capital letter A. It's going to have a different byte than the lowercase a or dash or the number 1 or the number 9. All of those have. You can look up the term ASCII. They go in depth more in the textbook. But you need to understand that everything a computer does is in ones and zeros, and it's all in bytes and kilobytes. About 1,000 of these things. That's about a page of information. A typed page is about 1 kilobyte. A song is about 1 megabyte. So MP3 is something back in the day we put them on iPods. Now you download a song to your phone. That's about 1 megabyte. If you're streaming a song on your phone, it uses about 1 megabyte for each song that plays on your phone on a streaming service. A gigabyte, that's one movie. A high definition movie is about 1.3 gigabyte. It's a billion bytes. It's a gigabyte. It's a billion bytes. And the movie is made up of all of those 8-bit registers, all holding a little bit of information that makes up the movie as a whole. A terabyte, that's 1 trillion bytes. That's 1,000 gigabytes, which is 1,000 megabytes. You get the idea. A terabyte, that's what our hard drives are currently at when we talk about size. A 10 terabyte hard drive probably cost you about $300, between $200 and $300, maybe $300 for a 10 terabyte hard drive. That's a big one. You can get 1 terabyte drives for about $60 on any online website or Amazon or wherever you shop. Now, I want to say, just to throw out how long I've been doing computers, I remember back in the 90s, I bought a 200 megabyte hard drive for $200. It was so big, I thought I was never going to use all of it. Never, right? Nowadays, my USB drives that I don't even use anymore because they're smaller are 8 gigabyte or 16 gigabytes. They're too small for me to use. And I have a terabyte hard drive, something that's 1 billion times bigger than that megabyte, a single megabyte. So anyway, so this is how we store bits and bytes. I'm going to go back to the previous page just because they talk, for some weird reason, they talk about preventative maintenance at this point. You really should do preventative maintenance, which is if you look really closely at the keyboard you're currently using, it's probably full of dust. Get yourself a can of air, buy it online on Amazon for $3, or anywhere you shop. I'm not selling Amazon. And blow out your keyboard, right? Blow it out or use some wipes with some appropriate cleaner for what do they call it? I think it's isopropyl alcohol. I might be wrong. What is the type of alcohol that you use to clean? I just buy wipes that are in a small packet, and they're purchased for this purpose of cleaning my keyboard. Every now and then I wipe it off. Is somebody going to Google that for me? Somebody in the classroom. Anyways, you can buy individual, or you can just, yeah, isopropyl, 90% isopropyl or higher, but don't just pour it on your keyboard, right? Especially if you're cleaning the face of your phone, right? You don't want to do that. You don't want to pour liquid on there and wash it like you do your car. You want to be more concerned about liquid getting into the computer. So use a damp cloth and wipes. They have a little picture actually of the wipes they use, something like this. You can buy those, 100 of them I bought them at a local big box store, and I think it was 300 for $10, and you can buy those online as well. Okay, we already covered that. Safety, make sure that you're cautious when you're picking up heavy computers and product. If you got a water cooled computer with multiple video cards in it, and it's got multiple hard drives, and all the bells and whistles, it could weigh 100 pounds, right? Everything RGB, it could weigh 100 pounds. Be careful when you pick it up, especially older CRT monitors, right? You're taking that out to the trash, probably, or recycle center, hopefully. If you have an old-fashioned CRT with the big tube in the background, I remember those. Anyways, today we have these nice, beautiful flat screens that weigh 20 pounds, right? Use proper lifting techniques to stay safe. At the end of the textbook, there is a list of computer terms. You really need to review that list, right? There's lots of terms, the ones I've covered in this presentation. And then if you're in my classroom or you have access to the ebook or the actual textbook itself, you want to go through those terms just to make sure you're familiar with them. We're going to keep building on these terms as we go through the course. So I want to make sure that you're building your knowledge as we spend the next 15 weeks together. And then if you take my second part of the A+, the 15 more weeks, 30 weeks of computer technology, you got to love it, but it's going to get you to the point where you can take the A+ certification. Again, this is an overview. This is the end of the course. This is actually a picture of the old book. I'll make sure I update the picture before we get to the new book. But this gives you, if you pause this, it gives you the name of the author, the name of the book, and just type in 8th edition if you're looking for an online ebook. Maybe you're looking for an ebook, maybe something combined with UCertify or some other online learning tool to be able to allow you to do some of the labs. We have in our class, we have UCertify and we have NetLab. So it's important for you to have access to some kind of lab material to be able to learn some of these concepts. All right. Anyways, let me go ahead and stop this sharing this screen. You should have me back on the screen. So that's chapter 1. That's a quick overview of chapter 1, really just an overview of what we're going to be talking about for the next 15 weeks or so. And I hope you stick with me as we learn more about computers. And in the classroom, obviously, if you want to get an A, you got to be here. But those of you that have found me on YouTube, I hope you watch all of my YouTube videos, and I will continue to build those videos as we move through this course. I haven't taught this course in a little while, so if you just picked up this video and you don't see any others in the playlist, it's because I'm building them as I go. So next week will be module 2, and then we'll go 3, 4, 5. We'll keep going through all of the modules. All right. So again, my name is Don, Professor Don. It's been a pleasure being your teacher this week. Happy learning. Hopefully you got something out of this presentation, and hopefully you continue to study and learn and get ready for your A+ certification. And I encourage you to ask questions and say hi. Heck, thumbs up my video down below. It really helps me out. And subscribe if you want to get notifications when that second, third, fourth video comes out. Or if you just want to see future videos when I make them, you want to get subscriptions. That helps me out as well. So again, thumbs up and subscribe. Ask questions down below if you have them. And I'll see you next week in class. Thank you for watching my video.